Before everything, before stars, planets, even space and time, there was nothing. No matter, no light, not even darkness. There was only a singularity, an unimaginably dense point containing all the energy that would ever exist. Then, about 13.8 billion years ago, that singularity expanded, not like an explosion in space, but the expansion of space itself. This event is what we call the Big Bang. In the tiniest fraction of a second, the universe inflated faster than the speed of light. Energy turned into particles. The laws of physics as we know them, space, time, gravity, snapped into place. For hundreds of thousands of years, the universe was a hot, dense plasma, a swirling fog of particles and radiation. It was too hot for atoms to form. Photons, the particles of light, kept bouncing off electrons, unable to travel freely. Then came a moment called recombination, around 380,000 years after the Big Bang. The universe cooled enough for electrons and protons to combine into hydrogen atoms. For the first time, light could move freely through space. That light is still traveling today. We see it as the cosmic microwave background, the oldest light in the universe, a baby photo of everything. The little orange spots here are hot spots where temperature was warmer. The surrounding blue areas are cold spots where the temperature was cooler. These fluctuations are where larger structures like that of galaxies would form later. Today, the cosmic microwave background is close to 2 degrees Kelvin. Extremely, extremely cold. For millions of years, the universe remained dark. But gravity had started to do its work. Tiny fluctuations in the density of matter began to grow. Hydrogen gas clumped together into massive clouds. And inside those clouds, the first stars were born. These stars were giants, burning hot and bright. In their cores, nuclear fusion forged the first heavier elements by smashing the protons of hydrogen atoms together. From this fusion process, helium, carbon, oxygen, and every other naturally occurring element was born. When these stars died, many exploded as supernovae, scattering those elements into space. That cosmic dust became the building blocks of everything. Future stars, planets, even life. As the wise Carl Sagan would say, we are made of stardust. Over time, stars grouped into galaxies, vast collections of billions of stars bound together by gravity. Galaxies collided and merged. Black holes formed at their centers. The gravity of these black hole singularities are so strong that not even light can escape their horizon. Cosmic structures like clusters and filaments began to shape the large-scale architecture of the universe. About 9 billion years after the Big Bang, in a quiet arm of an inconspicuous Milky Way galaxy, one star formed with a ring of gas and dust around it. From that dust, the planets coalesced, including a small rocky world we call Earth. On this planet, complex chemistry gave rise to life. And billions of years later, us. Today, we use powerful telescopes to peer into the past. The further we look, the older the light we see. We map the echoes of the Big Bang, measure the expansion of space, and search for the first galaxies. The universe is still expanding. This expansion is caused by a mysterious force known by astronomers and astrophysicists as dark matter, a force that acts as an anti-gravity, keeping the universe in expansion and not universe collapse, like some believed. In fact, this expansion is accelerating, driven by something we call dark energy, an even more mysterious force we don't quite understand. From a single point came everything. Time, space, matter, and meaning. We are made of stardust, atoms born in ancient furnaces, now capable of thinking, questioning, exploring. We are, quite literally, the universe understanding and finding beauty in itself. Isn't that a gorgeous thought? The universe has a story, a 13.8 billion year old story. This story, as we know of it at least, is still and only beginning.